Welcome to Archaeversity online lectures. In my previous lecture, I explained you how to calculate and analyze sign test for related samples. In case of a sign test for related samples, it only measures the direction of a differences from its median value. That is, if observation is a positive, then it will assign a positive sign. If observation is a negative, it will assign a negative sign. It will not measure the magnitude or the strength of direction. Now to measure the magnitude as well as the direction of a differences, we use Wilcoxon signed rank test. In this lecture, I'll show you how to calculate, analyze and interpret Wilcoxon matched pair signed rank test using IBM SPSS. So in SPSS, we can calculate Wilcoxon signed test using two different procedures. I'll explain those two different procedures with the two different examples. Wilcoxon matched pair signed rank test measures magnitude as well as direction of differences in the median ranks of a scores. The Wilcoxon test gives more weight to a pair which shows a large difference between the two conditions than a pair which shows a small difference. So large differences will be given a more weightage and small differences will be given a less weightage. It is used to compare two sets of scores that come from the same participants. So your independent variable remains with the same participants. Wilcoxon test can also occur when we wish to investigate any change in the scores from one time point to another time point, or when individuals are subjected to more than one conditions. So the conditions are the scenarios are similar to the sign test only. That is, one is your time and second one is a condition. So when you are measuring a time in two different time points, let us say one time point is April, another time point is June, and the condition is the respondents are given to a treatment A, then treatment B. Same respondents for two different types of treatment A, treatment B. Either of these two conditions, we use the Wilcoxon rank test. Now only the difference is that in case of difference between a sign test and Wilcoxon test is that Wilcoxon test not only just measures the direction, but it also measures the magnitude. So magnitude is also measured. When we say the magnitude, here it gives the importance to the scores. So more weight is given to the pair which shows a large difference, and less weight is given to the pairs which shows a small difference. Now what is that required is that your dependent variable should be measured on ordinal scale or a continuous scale, not on a nominal scale. So it is an ordinal scale or interval or a ratio scales. And independent variable should consist of two categories, that is related groups or a matched pairs. So that means independent variable is measured on nominal scale. So we can say that so your independent variable nominal scale and your dependent variable may be either ordinal scale or continuous scale. That is a ratio and interval scales. Now the distribution of differences between two related groups need to be symmetrical in shape. When we say the symmetrical in shape, we look at a symmetry that is normally distributed. So this is another requirement to run a sign test. That is Wilcoxon rank sign test. So here is one example. Normally when you try to purchase products, electronic products or books, something on directly in a store or from a website, there is online marketplaces, you will find differences in their prices. Sometimes the price available in a market, that is a physical store, is less. Sometimes the price available in an online marketplace is less. So here we give you a data. Using the data and applying the Wilcoxon ranks test, you need to determine whether there is a difference in median prices at a local bookstore and an online bookstore. So prices of a certain books are gathered for two different stores. One is a local bookstore and another is an online bookstore. So here it is not a time, but here it is a condition. So condition is the price At one place, one is your local bookstore and another is online books retailer. So here we have a data in SPSS. Right here we have a data before, one is a bookstore and second one is online. So bookstore price and online price. Now to calculate your Wilcoxon rank test for paid samples, so go to menu command, click analyze. From here non-parametric tests, legacy dialogues, then two related samples, because you are collecting the information from two different conditions. So pair 1 is a bookstore price, send to variable 1, online price, send to variable 2. So here Wilcoxon is by default, so keep this intact, click exact, then choose exact, click continue, then go to options and here choose descriptives, then click continue, then click OK. So result is here in output document. Now retail store and prices, we collected the prices for 19 different books but two different marketplaces, that is a bookstore and online store. So the deviation descriptive statistics are here. Ranks are here, negative ranks are 14, positive ranks are 5, and you can see that the sum of the ranks, because the rank test is based on a calculation of sum of the ranks. So sum of negative ranks is 139, sum of positive ranks is a 51. Then your test statistics is here. So test statistics says that the total is 0.07. At 5% significance level, we retain the null hypothesis, indicating that there is no significant difference in prices of a select 19 books in online store as well as a bookstore, or in an online marketplace and a physical bookstore. If your significance level is at 10%, then we can say that there is a significant difference in the prices. So we reject the null hypothesis at a 10% level of a significance. This is one example, and we look at the second example. So here the Ministry of Defense is considering which of the two shoe leathers it should adopt for its new army boot. They are particularly interested in how boots made from these leathers wear, and so 15 soldiers are selected at a random. So your sample is 15 soldiers at a random, and each man wears on boot of each type. After 6 months, the wear in millimeters for each boot is recorded. So use a Wilcoxon sign test to investigate the hypothesis that the wear in the two leathers is the same. Wear is decrease, or we can say that by usage, how actually the shoe is getting affected. Now here we have sample data. So leather A, leather B. Then to run your Wilcoxon rank test on a paid or matched data, so go to menu command, click on analyze, then non-parametric tests. So here related samples, click on the related samples. Then in objective, automatically compare observed data to hypothesis. Keep this intact. Move to fields. In a field, select your variables and send to test fields. Then next is your settings. So your choose test. From choose test, select customize tests, and from customize test, this time choose Wilcoxon matched pair signed rank. Then go to test options. So your significance level is 0.05. Keep this intact. Then click run button, and then go to output document. Here the result is presented. Now the result, you have a hypothesis test summary here. Now the hypothesis test summary says that the median difference between leather A and leather B equals to 0. This is a null hypothesis, which indicates that there is no difference. And the test conducted is related samples Wilcoxon signed rank test. Significance value is 0.04, which is less than 0.05 of your significance value. So reject the null hypothesis. So hypothesis test summary is here and with a decision. Now you have a values here, standard test statistics 2.02 and significance value 0.043, and graphs are presented here. Then your frequency distribution graphs are also here. So this is how you need to calculate Wilcoxon's signed rank test using IBM SPSS, two different procedures. So the difference between signed test and Wilcoxon signed rank test is that Wilcoxon signed rank test not only measures the direction of differences but also measures the magnitude of the differences. That is the major reason between signed test and Wilcoxon signed rank test. Thank you for listening to the lecture.